In this question, it says, in a game, each player throws 3 ordinary 6-sided dice. The random variable x is the largest number showing on the dice. So, for example, for scores of 2, 5, and 4, x equals 5. So for this one, we've got 3 dice, 3 ordinary dice, and x, so our random variable x, is the largest number that we roll. Okay, so for example, if we roll the dice and get 2, a 5, and a 4, then our x is going to be 5. Okay, the first question says, find the probability that x equals 1. So what is the probability that when we roll the dice, x will equal to 1? So in order for that to happen, the highest number that we roll has to be a 1 from all 3 dice. So the probability of getting a 1 on the first dice is 1/6. And the probability of getting a 1 on the second dice is 1/6, and in the third dice is 1/6. So I've got 1/6 to the power of 3. So the probability of that happening is 1 out of 126. For part 2, it says find the probability that x is less than or equal to 2. So we want to know the probability that x is less than or equal to 2. So how many different ways can I roll the dice to get a value that is less than or equal to 2? There's going to be 2 out of 6 ways for every dice. Okay, so it's dice 2 and then dice 3. So essentially it's 2 over 6 all cubed. And that is going to be 8 over 216. Then for the next part, it says, deduce that the probability of x equals 2 is equal to 7 over 216. So this one, the one that we just did, was the score being either a 1 or a 2. We only want the one where a score is a 2. So for that, so to find the probability of x equal to 2, I'm going to take the one that we just found, so including the 1 as well, so probability that x is less than or equal to 2, and then I'm going to take away the probability that x is equal to 1. Okay, so that's going to be 8 over 216 minus the 1 over 216, which gives us a 7 that they're looking for. 7 over 216. Okay, for the next question, it says, find the probability that x is less than or equal to r, and so deduce the probability that x equals r for r equal to 3, 4, 5, and 6. So it's just like what we did in the last question, except this time we're going to do it for 3, 4, 5, and 6. So we want the probability that x is less than or equal to 3. So that's going to be a 3 out of 6 chance for every dice. And that's 27 over 216. And then for that one, to find the probability that x is equal to 3, we're going to do the similar thing. So we take the probability that it's less than or equal to 3, and then we take away the probability that x is less than or equal to 2. So when we do that, we'll be left with the probability when x is equal to 3. So we have 27 over 216 minus 8 over 216, and that leaves me with 19 over 216. Okay, so we do the same thing again. The probability of x is less than or equal to 4. And again, there's a 4 in 6 chance for every dice, and we've got 3 dice. And that fraction would simplify to 8 over 27. So the probability that x is equal to 4 is going to be the probability when it's less than or equal to 4. Take away the probability when x is less than or equal to 3. So that is going to be 8 over 27 minus that, which gives us 37 over 216. Okay, so for the next one, the probability when x is less than or equal to 5. So there's a 5 in 6 chance for every dice, which gives us 125 over 216. So to find the probability when x is equal to 5, we use the same method. Less than or equal to 5, take away x less than or equal to 4. Minus 8 over 27, and that gives us 61 over 216. Now for the last one, we want to find the probability when x is less than or equal to 6. So how many ways can we roll the dice so that we land on any number between 1 and 6? So there's a 6 in 6 chance, yeah? That's probability of 1. And now, probability when x is equal to 6 is going to be 1 minus the probability when x is less than or equal to 5. So that's 1 minus 125 over 216, which equals 91 over 216.